So we've got a question here. Find the limit as x approaches 0 of 3 to the x minus 3 to the minus x, 2 to the x minus 2 to the minus x. So first things first, just plug in a 0 where you see an x. So we've got 3 to the 0 minus 3 to the minus 0 over 2 to the 0 minus 2 to the minus 0. Well, anything with a 0 in its power is just going to be 1. So even if you've got a negative here, because negative 0 is still near 0. So we've got 1 minus 1 over 1 minus 1, which is 0 over 0. So we've got an undefined function, undefined result here. So what do we do next to find this limit? So what we're going to do is, the first place to go to is L'Hopital's rule. So L'Hopital's rule. And what this requires is that you get a 0 over 0 situation, or plus or minus infinity over plus or minus infinity situation. So here, when we plug in our value here, 0, which we're finding the limit of, we get this first one. So that's ticked. Second rule we need is that split these functions here. The ratio of these two functions is f of x over g of x, where f of x and g of x are continuous and differentiable, and 3 of x, 3 to the minus x, 2 to the x, 2 to the minus x, these are all differentiable and continuous. So this is also met. So now what we can say is that the limit as x approaches 0 of f of x over g of x equals f prime of x g prime of x. So all I do now is take the derivative of the top and bottom and see where that takes us. Right. Okay, so 3 to the x. Let's take the derivative of that. That's a little bit awkward. So 3 to the x. So how do you take the derivative of that? Well, first of all, take the log. So we get x ln 3. And then what we need to do now, because we changed the value, we take the exponential of this answer, as exponential and log are inverse functions of each other. So then we get e to the x ln 3. 3 to the minus x will be the same here. So let's put that down here. 3 to the minus x. So take the log of that. We get minus x ln 3. And then just take the exponential of that. That gives us our derivative of that one. And then the same with the 2 of x and 2 to the minus x. We just change this to ln 2 and minus x ln 2. So we've got e to the x ln 3 minus e to the minus x ln 3 divided by e to the x ln 2 minus e to negative x ln 2. Okay, so we're now taking derivative of top and bottom, and we plug in our 0 here. So let's just write it down here. Limit as x approaches 0. Just plug in a 0 wherever we see an x. So e to the 0 ln 3 times ln 3 minus e to the minus 0 times ln 3, and the same on the bottom, 0 times ln 2 minus e to the minus 0 times ln 2. Okay, 0 times ln 3 and ln 2, these are all zeros. So we're still ending up with e to the 0 is 1, so we've got 1 minus 1 over 1 minus 1. Just make that a little bit neater. So 1 minus 1 over 1 minus 1, which gives us 0 over 0 again. So what can we do now? So basically what we can do now is use L'Hopital's rule again. So we've tried to find the limit here of this function. So if we just take derivative again and see where that takes us. Okay, so let's take the derivative of this. So e to the x stays as e to the x, but ln of 3 is a constant. So we can bring that out front. So ln 3 e to the x ln 3. That's our derivative of that one. Now this one here, we've got negative x ln 3. So basically negative ln 3 could be our constant here. So we bring that out front. Along with the negative here, we end up with a positive now. So positive ln e, and then the minus x ln 3, that stays. So, just make that ln 3, ln 3, e to the negative alex ln 3, that's that one. And now the same here, e to the x ln 2 comes out front. So we've got ln 2, as that's a constant, and then e to the x ln 2, that stays. Now we've got the same as we had in the denominator and the numerator, but this time with ln 2. The negative ln 2 comes out front, and with the minus ends up with a positive. And then the input for the exponential, that stays. Okay. Now this is looking a little bit messy at the moment, but we could factor out the ln 3 if we wished. It's got an ln 2 here as well, we could factor out that. Let's do that. So then that n equals ln 3 e to the x ln 3 plus, take the ln 3 out, e to the negative x ln 3. And then the denominator, same again, this time we take the ln 2 out. And then we're left with e to the x ln 2 plus e to the negative x ln 2. Okay, so bring this ln 3 and ln 2, that's just a constant, so that will stay as it is. Plug in a 0 for all these, so we get ln 3 over ln 2. 0, plug in 0 for this one, so e to the 0 of ln 3, so that will become 1, and then this one here will become plus 1, so e to the minus x ln 3, that's then plus 1 this time, because that's also 0. Again, plug in 0 here, we get a 1. Plug in 0 here, we still get a 1. Anything to the e to the 0 is always a 1. So that gives us ln 3 times 2 over ln 2 times 2. These 2's cancel out, and then we're left with our limit is natural log of 3 divided by natural log of 2. That is our answer.